In this video, we're going to be talking about our first abstract data type, the dynamic array. So, sorry, to start, we're just going to go over what a dynamic array is. And it's something that everyone has likely used before in C++ or in another programming language like Java or Python, and it is the vector. We use the term dynamic array as like a general term because in different languages this type of abstract data type is called different things. But the behavior of a dynamic array is basically, there's various constructors that allow you to create the dynamic array from the beginning. Oftentimes the default one is a constructor that creates an empty list. Each element has a place or index, and so there is order associated with the data that you can guarantee. And then you also have random access to each element, meaning if you want the fourth element, you can go in and access that directly. Because of that, you can also iterate through the list. The abstract data type of a dynamic array brings with it its size. It keeps track of its own size. It's able to make sure that you don't go outside of the bounds of its size. It also is an abstraction that's allowed to grow and shrink, so if you add more to it, it will adapt the memory automatically. Same as if you take things away, it's able to handle that as well, or it can. Most of the time, people just think of the dynamic array or the vector as an advanced array, assuming that there is some understanding of the basic array that comes with C. So it's basically a more advanced C array. In most languages, you are not able to mix data types within the dynamic array, so you need to declare the type that's held in the array in the angle brackets after the declaration. In C++, this is called a vector. That's the standard one that comes with C++ with the standard libraries. Java has the array list, JavaScript has arrays, Python has lists. So as you can see, they're called something different in every language. In C++, you need to include the library file in order to use it. So the standard one is vector, and the one that we're using in our class is called rvector. We're using it because we can provide the implementation file and you can start getting familiar with it now, so that when we start building them later, you'll have a good familiarity with how they work. So why not use C arrays? Well, C arrays are C arrays don't have all of this behavior that I've described here. They can't grow and shrink automatically. They don't know their size. You have to keep track of them themselves. They don't have bound checking, which allows you to go off into memory that you might not want or be allowed to use. And so abstractions like the dynamic array make for a much more usable container. So the implementation of a dynamic array could be anything. You could implement underneath, like inside of the class that you write, you could implement it using a C array. You could implement it using a linked list. You could implement it using a deck like we talked about in our live lecture. It could be anything. But what we're going to be talking about this week is not worrying about what the implementation is. So in order to be a user of an abstract data type like a dynamic array, you don't need to know the implementation, other than knowing the implementation helps you understand the efficiency of it. But the efficiency is usually included in the documentation or in the header file, and so you can look it up that way. So the point is that we really want you to focus on thinking about the abstract data type as this like tool in your tool belt that you can use, and it has behavior that's guaranteed without necessarily worrying about, well, how does it grow and shrink? How does it keep track of its size? Because you don't have to worry about that as a user of an abstract data type. But as far as implementation goes, you could implement a dynamic array using any other any data structure or any other abstract data type in many cases. And so it's kind of irrelevant to the discussion of its behavior today. And here's an example of why. So here I am showing you another another abstract data type that represents a dynamic array, but this is a user-defined one called vector, and it's different than the C++ library one that has a lowercase v. So instead it has an uppercase v, meaning that it's not the same one. It's something that's defined separately in a .h file. So the point here is that you don't have access to this implementation file and you don't know anything about how it's implemented. By using this vector class, you have no idea if it was implemented with a C array or a linked list or anything else, right? But by reading this code, because it's abstracted and it's so language friendly, you know what it does, right? So you can see that it has a function called add and insert. And because those names are useful, those names are consistent across most abstractions, you have a sense of how those would work. You might want to look at the details in the documentation of, okay, does it insert it at 0 or does it insert it after 0? Things like that, like little details that might not be obvious. But in general, you can see how this abstraction works. You can also see that it has a toString method, which could be used for printing it out to screen rather than having to iterate through it and print it out yourself. It has a remove method, etc. So this code is so much more readable and so much more usable and so much easier to solve interesting problems than if you were to worry about the implementation of any of these functions. So that's the whole idea of these abstractions, is they allow you to think about the problem rather than to think about the implementation. And as long as you have written the abstraction properly and implemented it correctly, this is a really powerful way to write code. So implementing a vector class could be done with anything, and I'm going to stress this a lot. You could implement the vector class with moonbees. So these are bumblebees on the moon. So once you declare a vector with the capital V implementation, just imagine that it could be literally that anytime you put anything into the vector like California, the California is taken by the moonbees off into the moon and stored there. And so if you ever need that first index that stores California, the moonbees would go and they would get it and bring it back. Now obviously this isn't a good way to implement the vector class, and it's not at all efficient, but the basic idea is that the functional behavior is what matters, not the implementation, when you work with abstractions. Now if you design abstractions, the implementation is really important, but if you're using abstractions, that's the idea. In general, for each of the abstract data types I'm going to talk about this week, I'm also going to mention what are typical applications. And it just happens to be that we're starting with the one that's hardest to define applications for. So dynamic arrays don't have like a very specific application that makes a lot of sense because they are so used in all different areas. And I guess the way that I would probably say it is that anytime one of the other abstractions isn't the right choice, the dynamic array is. So it kind of fills in any gaps where there's nothing better to use. It's also one of the few abstractions that's able to keep order. So if you want to keep your data in a specific order that's not sorted, or not alphabetical, but you want to keep the order in some other odd way, like for example insertion order, the dynamic array is the way to go. But then otherwise, they are really useful. That's why you've used them so many times before in keeping collections of data, but you really need the right balance of performance and speed in order to use them. So to wrap up, abstractions are a great tool for you to use, and you're already used to using them because everyone has used dynamic arrays before coming to this class in some other language. So like I said, if you're in Java or Python or JavaScript or any other language that has these types of abstractions built in, you've already used it. So now what we're going to be doing in this class is getting familiar with the C++ abstractions that are available, and then we're going to start building our own. So this is one of the first ones that is easy for students to understand because you're so used to it. So I really encourage you to as you're working on the first couple projects, to dig into the R vector implementation file and familiarizing yourself with that file and how it's set up. It will really help you digest later when we start writing those ourselves. All right, that's it. Thank you so much.